Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3452, Theory of Computation, Unit 5, topic Recursive Enumerable Languages. Objectives to understand the properties of recursively enumerable languages. Recursive enumerable languages. Recursive enumerable languages or type 0 languages are generated by type 0 grammars. Here the language can be accepted or recognized by Turing machine, which means it will enter into final state for the strings of languages. It may or may not enter into rejecting state for the strings which are not part of the language. It means Turing machine can loop forever for the strings which are not a part of the language. Here the languages are also called as Turing recognizable languages. Next, we are going to see the recursive languages. In this diagram, it shows the subset of recursive enumerable. It can be decided by Turing machine, which means it will enter into final state for the string of language, and also it can able to rejecting state for the strings which are not part of the language. So the recursive, because we can construct a Turing machine which will move to final state if the string is of the form. Else we have to move to the non-final state. So only the Turing machine will always halt in this case. Here the languages are also called as Turing decidable languages. Here the relationship between the languages can be RE and REC. Then next we are going to see some closure properties of recursive languages. Union. If L1 and if L2 are two recursive languages, their union L1 union L2 will also be recursive, because if Turing machine halts for L1 and also halts for L2, it will also halt for L1 union L2. Next we are going to see the concatenation. If L1 and L2 are two recursive languages, their concatenation L1 into L2 will also be recursive. For example, for L1 we can consider some set of strings, L2 we can consider some set of rings. Using the concatenation, you can make a recursive enumerable. So only it is also called as a recursive. That means here L1 says number of A's followed by number of B's, and the B's followed by number of C's. Here L2 says number of D's followed by number of C's, and also it followed number of F's. So their concatenation first matches number of A's, B's, C's, and then matches only D's, E's, F's. So only it can be decided by the Turing machine. Next we are going to see the closure properties in clean closure. If L1 is recursive, its clean closure L1 power asterisk will also be recursive. That means L1, that it should be considered as L1 power asterisk. The next one is intersection and complement. Here also if L1 and L2 are two recursive languages, their intersection L1 and L2 intersection. Here also we have to consider two languages L1 and L2, then it will consider L3 equal to L1 plus L1 into N2. That means here L1 says number of A's followed by number of B's followed by number of C's, and then any number of D's. L2 says any number of A's followed by number of B's followed by number of C's followed by number of D's. Their intersection says number of A's followed by n number of B's, it followed by n number of C's, then only it followed by n number of D's. So only here they can able to decide by Turing machine, hence recursive. Complement recursive language, which is sigma asterisk, is also be a recursive language. Thank you.